Okay, this is our second video on lesson 1 about standard form to scientific notation, or scientific notation to standard form, which is what we're going to be doing today. So these were the notes that we took in the last video. You want to make sure that you have your lesson 1 out, and you also want to make sure that you have this paper close by. So we're going to start, the last thing we talked about before you were supposed to do numbers 1 through 23 on the independent work. The last thing we talked about is the difference between big numbers and little numbers, or numbers less than 1, in scientific notation would be that they have negative exponents. So now we're going the other way. We're going to go from scientific notation to standard form. So if you have a number like this, okay, if you have a number like this, how do I make that into standard form? That's where we're headed today. All right, I know that there's a little bit of a glare in the video. I can't get rid of it because of the camera. I will try to stay out of the glare. If you have any questions, please let me know. So, the first thing we're going to do when we have, I don't know if you can see it way down here, the first thing we're going to do when we have this number right here is we're going to write down the coefficient, which is the part of the scientific notation that is before the times 10. Well, that's pretty simple. Here's the before times 10, so I'm going to write down 7. Here's the before times 10, I'm going to write down negative 7. Okay, so far so good, right? On number 2, by the way, if you need to stop the video because I'm going too fast and you can't get things written down, pause it and then write down what you need to write down. All of the information is on this paper at the bottom here. And then start back up so you don't miss things. Okay, so you're going to be starting where the decimal is right now. In that number, you are going to jump the number of times the exponent tells you, making neat loops, or making a neat loop for each jump. Whew, all right. Where is the decimal? Here. I don't see any decimal. That's because it's invisible. It's right there after the 7. So here's where the decimal is. I have to make this many jumps. In this case, it's 9. And for each jump, I'm going to make a nice, neat loop. If you make your loop sloppy, it's difficult. Seriously, this is an activity that needs to be done with a sharp pencil. I'm using a sharp pen. The only reason I'm using a pen is so you can see it, so it shows up well. So we're going to make 9 loops. 1, 2, 3, 4, 5, 6, 7, 8, 9. When I get to the end of the 9th one, I'm going to show what was jumping, my decimal point. It's not there anymore. It's over here. Okay, I'm going to skip the next part of this for just a minute so I can finish doing this problem. It says, fill zeros in any empty loops made from jumping. Well, look at all these empty loops. So I need to put a 0. This is why you need to make your loops really neat, so you can see how many times you need to put zeros in. Some people think, oh, I need the number of zeros that there's the exponent. No, that is not the number of zeros. That's the number of jumps. Okay, so there I have it. Now, Do you think that that looks like a nice, neat answer that I can tell what in the world you mean? No. So, after you do it, when you are going from scientific notation to standard form, you have to rewrite the standard form of the number neatly. Be careful. There are no numbers that have 2 decimal points in them. Think about what happened to this decimal point. It started here, it jumped to here. It is no longer right there. Do not put the decimal point right there, or else you still just have 7. Do not put 2 decimal points in it. Make sure that the decimal point goes at the end, or if it's at the very end, you don't really have to put it in at all. But you need to make sure that you neatly rewrite this, and after obviously, look at how not neat my handwriting is. It doesn't have to be perfect, but it has to be legible. Then put your commas in. How do you do commas? You start over here where the decimal point was, and you go 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. And there is your standard form. Well, look at these two. This was 7 times 10 to the 9th, and this is -7, but it doesn't matter if it's negative. I'm going to ignore that for a minute. Times 10 to the -9th. How do I know which way to jump? If I jump 9 going this way, I'm going to get this exact same number. So that's where this part comes in. It says, if the exponent is positive, which it was in this first one, it was positive, then the number should get larger or bigger, either one. Did this number get larger? It was 7, it's now 7 billion. Is 7 billion larger? Yes, it got larger. If the exponent is negative, the number should get smaller. Actually, it's the absolute value of the number that should get smaller. We're going to ignore this negative out here for a minute. So how do I get this to be smaller? Do I add zeros over here? Did that make it, remember we're ignoring that, did that make it get smaller? No, that made it get bigger. But what if I took, here's my 7, and what if I took and I made the jumps go this way? So I put a 0 here, and now my decimal point's here. Ooh, that got smaller, didn't it? Because 0.07 is smaller than 7, correct? So how many jumps do we need to make in a negative direction? 9. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my new decimal. Don't forget to do that part. Then fill in the loops with zeros. I already filled in that one. This decimal point is not here anymore. It jumped all the way to there. Now I have to rewrite this number. Remember, it's negative, so put the negative out front. And here's your answer for that. Okay, guys, look. What's this number? A 9. Are there 9 zeros here? 1, 2, 3, 4, 5, 6, 7, 8. This says the number of jumps. It does not say the number of zeros. The number of jumps, the number of loops. All right, let's try this one. This one is a positive, so my number is going to need to get bigger. First step, write down the coefficient. The second step, start where the decimal is, make loops, the number of jumps that it tells you from the exponent. 1, 2, 3, 4, 5, here's my new decimal point. Fill in zeros in the empty loops. Rewrite it. Be careful. Where's the decimal point? Is it here or here? It's over here. It jumped that way, remember? It's not there anymore. It's here. Then we go 1, 2, 3, comma. We can double check. This was positive. Did this get bigger than this? Is 493,000 larger than 4? Yep. There's my answer. This one is going to get smaller. Here's a little hint when you're writing these for having enough room. If it's one that's going to get smaller, put it over on the right-hand side of the paper as opposed to putting it over on the left-hand side, because you're going to do your jumps that way, because I want this to be smaller than 4. I'm going to jump 5 times in a negative direction. It was here. It's going 1, 2, 3, 4, 5, and now it's here. It's no longer there. This loop already has a 4 in it, but this loop and this loop and this loop and this loop need zeros to fill it up. Rewrite it neatly. This was my decimal point. Do I put a decimal here? Are there going to be 2 decimal points in this number? No, there's never 2 decimal points. And there's my final answer. You take a moment and see if you can do those 4, and then come back and check them. Okay, so this is a negative one, so I'm going to start it over here. And it's going to do 6 jumps in a negative direction. 1, 2, 3, 4, 5, 6, new decimal. Put zeros in where my loops were. Rewrite it neatly. Oops, forgot my decimal point here. No decimal point here, because it's here. This coefficient was negative, which means the whole thing is negative. And there's my answer. The next one, it's going to be positive, so I'm going to go ahead. It's going to get bigger because it's positive, and I'm going to put it on this side. 6 jumps. 1, 2, 3, 4, 5, 6. Here's my new decimal point. That decimal point doesn't exist anymore. Fill in and rewrite neatly. Is there a decimal point here? No, because the decimal point's now over here. But I don't have to write it. I go 1, 2, 3, comma, 1, 2, 3, comma. It's a positive coefficient. There we have it. On the next one, it's positive exponent, which means the number is going to get bigger. So I'm going this way, only 2 jumps. The original number, the original coefficient, was negative, so that's the only reason the negative goes here. Not because of a negative exponent, but because of a negative coefficient. Write it neatly. Hey, this ended up over here. Do not put a decimal point there. And there you have it. And finally, this one's going to get smaller by 2 spaces. 1, 2, new decimal point. This loop is full, but this loop was empty. It needs to get full. Do I put a negative out here because that's a negative? No. Why did I put a negative here? Because the coefficient was negative, not the exponent. Now, if both of them are negative, then you're going to have a negative out here. But it's only if the coefficient has a negative. So I rewrite it, decimal point, 0, 9. Do I put a decimal point here? No. 1, because we only have one decimal point per number. Now, we can do some double checking. This was negative. Did this get smaller? Yes, 9 is bigger than this. This was positive. Ignoring the negative sign for a minute, did this get bigger? Yes, it got bigger from 9 to 900. Did this get bigger? It's positive. It should have gotten bigger from 8 something to 8 million something. Yes. Did this one get smaller? Yes, it did. See this right here? That's what we just did. We double checked that the numbers that have negative exponents in scientific notation are less than 1, and those with positive exponents are greater than 1. Okay, the last thing for you to do for lesson 1 is to do numbers 24 through 35. And then we can move on to lesson 2. Ask me some questions if you have any.